It's great to finally be here at Demo Day. My name's Guy. I'm the lead development engineer at Composite Braiding, and today I'm pleased to present to you the results of 6 months of hard work from all our team exploring the future of composite rail infrastructure and OLE. For a quick bit of context, we're a 10-person SME based in Derby, and we manufacture lightweight, high-strength composite components for a very broad range of industries and applications. We're well positioned to produce high volumes of sustainable composite components, which historically has been a significant challenge for the UK composite industry. I'll talk a little bit about how we do that later on. For this programme, we had a simple aim: to show that composite rail infrastructure is not just a viable alternative for steel, but brings substantial mechanical, economic and environmental benefits. To do so, we decided to manufacture one of the most challenging assemblies seen trackside, a twin-track cantilever, as you can see in the picture on the slide. We set out 3 principal requirements for our composite version. It has to match the loading requirements of the existing structure. It has to be more sustainable, and it has to be easier to install. Each of these requirements was considered by a different aspect of the project: materials, manufacture, and installation. For material, our structure is almost entirely constructed from nylon, reinforced with continuous glass fibre braid. This is the key factor that generates most of our gains. The high specific mechanical properties, strength and stiffness, enable a huge weight saving of over 84%. It's environmentally inert, fire resistant, and it's one of the lowest cost composite materials available on the market. Crucially, it's also non-conductive, so no further insulative material is needed to operate in high voltage environments. And as nylon is a thermoplastic, it can be remelted at high temperature, allowing for repair and recycling at end of life. For manufacture, high-rate manufacturing of thermoplastic composites is really our bread and butter at Composite Braiding. This video shows our larger braider at work, for those of you not familiar with the process. We've refined our braiding technology over a number of years to the point where we can now produce up to 1 mile a day of braided preform on a single machine. An optimized production run scraps less than 2% of the material used, and that scrap can be reprocessed into additional products and services, enabling essentially a 100% material utilization rate. Our patented induction molding technology enables a significant reduction in both consolidation time and energy usage compared to in-autoclave or oven methods. This puts us in a really strong and unique position for the future, where we can mass produce large composite structures such as our TTC. Whilst the benefits of the composite structure are generated by the material, they're seriously demonstrated during the installation process. The significant mass reduction means fewer access and assembly provisions are needed, service roads, lifting and transportation equipment, not to mention how much less concrete is needed for the foundations in such a structure. This also decreases risk to workers. The total mass of the structure is less than 280 kilos, and 60 kilos of that is the steel feet, making the structure much more easily maneuverable and installable. We estimate a reduction in installation time from 30 minutes to just 15, crucially reducing boots on ballast and improving efficiency in possession usage. So, to summarise, we can broadly categorise the benefits of composite rail infrastructure into 4 key areas. Reduced mass is our main driver and ultimately leads to lower install costs per unit, improved worker safety and reduced installation time. Ability to easily adapt designs means each unit can be tailored for its given application, both mechanically and aesthetically. Our in-house production technologies enable low-cost, high-volume production of high-performance composites that's repeatable, predictable, and easily scalable. And finally, by using thermoplastic materials, we can manufacture rail infrastructure that is truly sustainable, low waste, low energy usage, recyclable, and repairable. We'd like to thank the teams at CPC and BCRMO, whose support has been invaluable over the programme. We'd especially like to thank Amy for their advice and assistance with the installation of the prototype, as well as Keltbray, Skanska and Unipart Rail for their contributions to our advisory board. Thanks for listening, and please do come and see us on the exhibition stand and at our prototype outside.